Okay, welcome to lesson 116, degree of a polynomial. Obviously, this is probably a part 2, but let's get into it. So if you did not watch 2115, please watch that video before you watch this video. Here's our objective, our vocabulary, and let's get into it. So I want you to pause the video and read through the vocabulary and take your time with that. So let's look at, we looked at monomial in the last video. We looked at how we count degrees. So when you have a monomial, such as the first one, 11x, this 11 is called a coefficient. The x is your variable. And if there's no power written, it's a 1. So I'll put the powers in blue or red, and I'll tell you the difference between a power and a coefficient. So monomial, one term. You can multiply and divide for monomials. Monomials are different when they're added and subtracted. They're called different terms. So let's look at the next monomials at negative xy squared. The number in front is called the coefficient. There's no number, so we will put a negative 1 out front. The x has no power, but we will put a 1. And the reason why we eliminate ones in math is because it is redundant, it's extra. So you have 1 there, so you don't need to write, because anything to the 0 power is the number 1 except for 0. So that's why we don't worry about first degree. So we just know it's to the degree of 1 because it's one is the letter or the number or whatever term is there. So xy squared. In a monomial, you add all of the degrees together, the powers together, and that's how you get the degree of your monomial. It's the degree of the monomial only. So again, on the next one down, 2 is our coefficient. We have 2 variables. You add them all together, and you get to 7. So on the fourth one, 5 is our coefficient. We have 4 variables that get added all together, and they add up to 10. This is a 10th degree monomial. And we change those things when it gets to polynomials. All right, and let's look at some polynomials. Polynomials. Poly means many. Many named terms is the actual translation of polynomial. So our first term, 5y squared. Y squared is the highest term. You cannot add and subtract letters together. So this is a second degree polynomial, which we will call a quadratic. Binomial. Bi means 2 terms, 2 named terms. Okay, let's look at our next term. Our leading term, m squared n cubed, and we can see the degree of that monomial is a 5th degree. Some teachers may touch on this, but I'm going to just teach it to you. So this is a 5th degree, and there are 3 different terms here, so we call this a trinomial. So a lot of teachers probably won't even worry about the degree. They'll just say, you know, your m squared n cubed have the highest amount of exponents. So you just put that first as your leading coefficient to write it in standard form. Okay, looking at our third example here, these are 2 separate terms. Remember, you cannot add a number to a letter, and you cannot add letters of different powers, even if they're the same letter. So this is degree 1, so it'll be first degree. It's 2 terms, so it's a binomial, but it is not written correctly. So you always write your variables first. Because there's no sign in front of the 19, we know that it's positive. And now it's written in standard form. And so let's go through this chart. Let's talk about some polynomials. So you have, when you have a number by itself, it's called constant. When you have a first degree variable is linear. A second degree is called quadratic. A third degree is called cubic. A fourth degree is called quartic. And a fifth degree is called quintic. A lot of math teachers probably won't use these, but we definitely use the first three. Quadratic. A quadratic, and we'll get to graphing later, but when we get to that, they make a specific graph. But when you're talking about quadratic, you're talking about area. So anything to the second degree, you're dealing with area. So let's call this length, and let's call this width. So that's for quadratic, and that's why we call it quadratic, and it has a special graph. Cubic. Cubic terms deal with three-dimensional shapes, and the most common three-dimensional shape is some type of cube, whether it's a rectangular cube or a square cube, and that's why we call this cubic, because it has a length, a width, and a height. But quartic and quintic, I wouldn't really worry about it. And the linear term. Linear terms make a special type of graph. I'm not going to talk about graphs right now. We'll get off into that later when we get to graphing. But for right now, all I'm dealing with is how to do functions with polynomials. Okay, so write the polynomial in standard form and give its degree. So you can put the ones in front of here, but it's not necessary. So like I said before, the highest degree term goes first. And this is a third degree, a cubic, which equals third degree. Two terms is a binomial. Okay, so now let's look at this. There are no x's with the same term, so let's move this around. X to the seventh is the highest term, plus x to the fifth minus 2x squared plus 1x. So this is the seventh degree, going by the highest term. Polynomial. Anything more than three terms is just poly. Poly means many. Nomial, again, means named terms. Nomial means name. Okay. Describe each polynomial by name based on degree and number of terms. So you have a cubic, three terms, 1, 2, 3, trinomial. Again, when you're combining terms, x cubed and x squared do not have the same exponent. You cannot add them together. All right, so evaluate the polynomial when x is 3 and -2. So what I'm going to do is put the x equals 3 in blue, and we'll substitute -3 to the 5th power minus 3 cubed minus 11 times 3 plus 2. Okay, 3 to the 5th power. Let's see, what is that? 3 squared is 9, 3 cubed is 27, 3 to the 4th is 81, 81 times 3 is 243, -243 minus 27 minus 33 plus 2 is -301. Okay, so I almost forgot to do the second term, so let's do it in red. And this makes a difference, and this is why we substitute in parentheses. So watch how this gets done. -2 to the 5th power minus -2 cubed minus 11 times -2 plus 2. Okay, so watch this. 2 to the 5th power. 2, 4, 8, 16, 32 is negative of -32 minus -8 plus 22 plus 2. Two negatives make a positive, so you have 32 plus 8 plus 22 plus 2 gives us 32 and 8 make 40, 22 make 30, 40 and 30 make 70. So please Be careful when you substitute, use parentheses that will keep your sign straight. Because I can see a lot of you putting a negative outside and they get negative 32 and all that kind of stuff. These are typical mistakes that are made. So how you keep that straight is when you substitute, use parentheses to keep the sign straight. Okay, so thank you. So those were our 3 examples. I will ask you to pause the video, do the practice examples, do the problems coming up, and I will see you at the end of the video for a recap. Okay, write the polynomial in standard form and give us degree. 7 is the highest term, so 8y to the 7th plus y cubed minus 4y squared. So this is the 7th degree. 3 terms makes it a trinomial. Okay, so we got nothing in common. So the 11 is the highest term, negative 2x to the 11th plus 2x to the 9th minus x squared plus 9. Everything 11, 9, 2 is in order. So you have an 11th degree. 4 terms makes it a polynomial. Okay, so let's see. Describe each polynomial by name based on degree and terms. So 2nd degree means quadratic. And then 2 terms is a binomial. So when we name polynomials, you can see the degree goes first, then the how many terms. So you can easily tell. And there's the reason for the standard is standard all across the world. So if you're dealing with somebody in a different country, they should name it the same way. You deal with the power, the exponents first, and then you deal with how many terms in your polynomial. So evaluate the polynomial when z equals 5 and negative 5. So let's do this in blue again. 2 5 cubed plus 4 to the 5th power, 5 squared, minus 5 plus 2. 2 times 125 plus 4 times 25 minus 3. 250 plus 100 minus 3. 350 minus 3 is 347. Okay, let's do negative 5 in red. 2 times z cubed, 5, negative 5 cubed. And you see why we use signs to keep we use parentheses to keep our signs straight. And it's going to make a big difference in this one. All right, so negative 5 cubed is negative 125 plus 100. 4 times 25 plus 5 plus 2. So 100 plus 7 plus negative 250. So negative 250 plus 107 minus 250 minus 107 is what? 143, negative 143. All right, so that is the end of this video. Thank you for watching, and be prepared. This is what? This is the second. There are about 17 or 18 videos left dealing with polynomials. So I'm going to cover all facets: adding, subtracting, multiplying, dividing, all of that. Even long division of polynomials I'll get off into. So thank you again for watching, and I will catch you on the next video.